Hello there, I'm Charles Ross, the Service Hydrologist at the National Weather Service office in State College. Today we're going to look back at a phenomenally heavy rainfall event that affected north central Pennsylvania and adjacent New York State on the 17th and 18th of July in 1942. That's 75 years ago this week. Particularly hard hit counties in central Pennsylvania included Elk, Cameron, McKean, and Potter. There were 15 deaths attributed to the floods. The National Climatic Data Center acknowledges this event with the following comment. This is arguably the greatest 24-hour rainfall on record outside of the tropics that occurred around Smethport, Pennsylvania on July 17, 1942. A post-event survey by the Weather Bureau provided a widely accepted maximum storm rainfall of 34.5 inches within a 12-hour period, of which an estimated 30.6 inches fell in just 6 hours. However, the greatest observed 24-hour rainfall for Pennsylvania occurred in conjunction with Hurricane Agnes in 1972, when 13.5 inches was observed near York. This occurred during the height of World War II, and many of the communities affected were supporting the war efforts that were going on, and they were heavily impacted by this event. The presentation will also include information from a variety of sources, which I'll reference at the end of the talk. Leading up to the flooding, the region was in the middle of a heat wave. The Pittsburgh Post-Gazette newspaper reported that western Pennsylvania was in the midst of a 3-day heat wave that saw temperatures rise to 96 degrees on the 17th, with a morning low of just 77. Additional reports mentioned the city's public pools and rivers were jammed with residents seeking relief from the heat. And as you can see here, there were numerous high temperature records set across mostly the eastern United States during this period. Using NOAA's 20th century reanalysis data to reconstruct the weather patterns for this time, we see the region is in a hot summer pattern. But it's also favorable for mesoscale convective complexes to form, which often leads to heavy rainfall. So here's a time sequence of the 500 millibar heights and anomalies. You can see a large-scale evolution of the subtropical ridge here on the 13th through the 18th. So starting here, you'll see this ridge builds on the 13th and 14th. It's undercut a little bit by a trough low pressure going across New England and the Northeast states, but it builds right back, and by the 18th and into the 19th, you'll see the region has a northwest flow with a trough again to the north. This is favorable right here to be what is known as the Ring of Fire, and we will see storms traverse this area right here between the cooler air to the north and the much warmer and muggier air to the south. Now we're focused closer to the event here. This is from the afternoon of the 16th through the 19th of July, centered more on Pennsylvania and the East Coast. Looking at the 850 millibar heights, you'll see that we have this retreating cooler air at 850 millibars with a much warmer, huge dome of warm and moist air across the central U.S. that begins to push its way into the Northeast through the period. It should be noted that ahead of the event, it was quite cool across the area, northern Pennsylvania, with a lot of temperatures in the 40s on the morning of the 16th. Obviously, with this warm and moist air quickly moving in, things changed rapidly. Here we're looking at the precipitable water charts on the 17th and 18th. They show a large increase in moisture coming over the ridge from the northwest into the region. Precipitable water values were over 2 inches. It's quite anomalous for this time of year, and it's a big ingredient needed for extreme rainfall. This developing pattern is indicative of an ideal Ring of Fire or MCS pattern. And we'll finish up by taking a quick look at the 850 millibar winds. Looking here, you can see a strong west to east jet shaping up over the region on the 17th and 18th. I'm not going to show you here, but the surface pattern did show a frontal trough moving through during this time. And we'll summarize by saying that the weather pattern implied a developing subtropical ridge and heat wave with a heavy rainfall event on the periphery of the building ridge, and that all set up over northwest Pennsylvania and southern New York. And now we'll take a look at what happened from this. Here's an image from the USGS report that shows the area that was hit from the flooding. You'll see it's a rather small area, and one thing to note is that there are three distinct river basins that were affected. You have the Allegheny headwaters right here, you have the Clarion River headwaters here, and the west branch of the Susquehanna River flows eastward this way. This actually was a good thing in that had all the water from this copious rainfall gone into one basin, the flooding would certainly have been worse. As shown in the previous slides, we believe this heavy rain and subsequent flooding was triggered by a mesoscale convective complex or a series of complexes ahead of the building ridge. This is a known classic weather pattern for summertime flooding and heavy rain across the eastern United States. The heaviest totals that were measured during this 12 to 24-hour period was 8.22 inches in Coudersport and 8.1 inches in Emporium. The gauge at Smithport did register 6.68 inches before it was destroyed. James Stewart was a hydraulic engineer from the West Penn Power Company back then, and he surmised that rainfalls higher than those totals shown in the previous slide must have fallen given the magnitude and the impacts from the floods. Near Port Allegheny, we're looking at a slide here of the Apholt farm. He found a farmer here who had his container out shortly before the rain began, and this container filled up and was reported to have had 30.8 inches of rain. Stewart then brought this to the attention of the U.S. Weather Bureau and the U.S. Corps of Engineers, and a joint conference was held in Pittsburgh. And from that conference, they made an agreement to conduct a survey of all available precipitation from the storm. So here's a copy of the survey that was sent out to just about every property owner in the region. From this, they were able to obtain about 500 new data points. He found that many of the farmers had actually put out containers to measure rainfall. Apparently, this was a common practice back then, and from this, he was able to recreate rainfall totals for the event. From the work of this team, in 1944, the U.S. Weather Bureau published a hydrologic supplement detailing the nearly 500 sources of precipitation that they used. Shortly afterwards, the USGS published a report detailing the extreme hydrologic conditions and flooding that was observed, though the final publications were delayed given the war efforts. From this, an isohydral map was produced, and it really shows the localized extreme nature of this event. Looking here, here's New York State and some of the heavy rainfall that fell between the border and Olean. Moving south, you'll see you have Smithport right here, Coudersport over here, and Emporium down here. So in this triangle area here, we were seeing totals anywhere from 6 to 8 inches to these small pockets of 30 plus inches of rain that they observed from their survey. So all this rainfall quickly led to major impacts across the region. Here's a brief but certainly not all-inclusive list of some of the damages that were observed. Public utilities, transportation systems were all badly damaged. Roads, bridges, railways were all washed out. There was a passenger train near Ridgeway that was marooned. Several rail lines were damaged and they were never rebuilt. The dikes at the town of Emporium were overtopped. 60% of the town was flooded. They reported 5 feet deep water in the middle of Broad Street Square. At Austin, which was the scene of the historic dam break in 1911, which killed 80 people, the Williamson Pulp and Paper Company's reservoir was again breached. The town was flooded, and many buildings were knocked off their foundations. 4 to 5 feet of water on Main Street. In Port Allegheny, they suffered damage to virtually every building with 3 to 20 feet of water there. There was a gathering in a local church when the floodwaters hit, and over 150 people had to be rescued from treetops, roofs, and floating wreckage. Above Johnsonburg, a dam broke there, sending an 8-foot wall of water towards town. 8 families were rescued on makeshift rafts. Other towns reported damage included Smithport, Eldred, Bradford, and Ridgeway, as well as Portville, Olean, and Salamanca in New York State. This resulted in 15 losses of life, and fortunately, the USGS report points this out, and I mentioned this earlier. Very likely would have been worse if this rain did not fall at the intersection of 3 different river basins. If it had all fallen in one basin, there would have even been more flooding in a more localized spot. So it was fortunate the geography sent the water in 3 directions. Is this a record? The answer is yes and no. When you search the internet, you'll see many references to this as a high precipitation record, and at some point it has been classified as a record. However, when you go to the National Climatic Data Center website and you look at the greatest 24-hour rainfall total, it was 13.5 inches near York during Agnes in 1972. However, they do mention the Smethport rainfall total in a footnote. So it's really a tough call as to whether or not it's a record. Regardless, it goes down as one of the more unusual and interesting weather events in United States history. Not as widely reported, given that it was in the middle of World War II. There was a lot going on in the world, obviously, but we remember it here 75 years later. It's one of the more interesting events, both in the United States and in Pennsylvania weather. I'd like to take a quick moment to acknowledge several people that helped out on this. Rich Grum is the Science and Operations Officer here at the National Weather Service office in State College. On the next slide, I'm going to reference his case study. He worked quite hard at getting the reanalysis data for us and really looking at this from a meteorological point of view. Again, pretty fascinating storm. Thanks to Rich for his help with that. Mike D'Angelo and Aaron Tyberski found some great references on the web, put together some nice slides for this talk. Appreciate that. We have a Holling student at our office right now. Her name is Alyssa Smith. She's from Texas A&M. She produced a couple graphics as well. Thank you to them. And finally, we'll look at some references. As pointed out in the last slide, the case study that Rich Grum produced is available here. The much referenced USGS flood report can be found here. There's 2 really interesting websites to look at some of the photos from the event. This genealogical page and from Ginny and Painted Hills are both filled with lots of interesting photographs. Thanks a lot for listening to this and hopefully learning a few things about a really fascinating case in Pennsylvania weather history. Y'all take care. Enjoy the rest of your summer.